Okay, 5 through 8. So we're looking at question 5. Still, there are no like terms that we need to combine, so that makes things nice. Okay. Let's get our variables to the left. Actually, let's put them to the right. Why not? Let's move our variables. So let's say I wanted to get this 5p out of there. I would subtract it from both sides. And I'm just showing you that it is perfectly fine to put the variables on the right and the constant on the left. It doesn't change anything. So the 9 would come down. And 5 minus 5 is nothing. That's why we did that. 7p minus 5p is 2p. So see, we avoided, by putting the variable term on the right, we avoided negatives. So some people do like to do it like that, like figure out where they're going to avoid negatives. And this plus 3. So now we're getting our constant terms to the left. So this 3 needs to go. So we would subtract it, right? Because 3 minus 3 is nothing. That's why we did that. 9 minus 3 is 6. And again, we're just trying to isolate the variable. We're trying to get that p alone. So 2 times p, you divide by 2. This is a giant 1 now, right? Because 2 divided by 2 is 1. So 1p. But really, when you type it in, just put 3. All right, so here we do have to combine some like terms, right? I've got 2 variable terms on the left. I've got negative 4x plus 4x. Oh, negative 4 plus 4 is nothing. That worked out. So we've got this negative 5 equals 2 plus x. And instead of moving that x to the left and then moving everything, I could just like get rid of this 2 and call it a day. So that's what I'm going to do. So I'm going to subtract the 2 from both sides, right? Because 2 minus 2 is nothing. So I did get the x all by itself. It just happens to be on the right. You owe me $5 and borrow 2 more. So your final answer would be that. All right, again, we got 2 variable terms on the left. So we have 1x and 5x. So let's condense. So 1x plus 5x, 6x, equal sign. So this is another place where I could get all the variable terms onto the left because that's sort of what people feel cozy with. But then all of a sudden you have like a negative x and stuff gets weird, right? But if I decide to bring the x's to the right, if I subtract this off of both sides, then what happens? Well, the negative 6 here comes down. 6x minus 6x is nothing. Got 1. And then 7x minus 6x is 1x. So I just got a plus 1x here, but I don't really need to write the 1. I can just write x. All right, so I brought it to the right so that I could avoid negatives, and that worked out really well. Now I have to get the constant term. I have to get this 1 off to the left by subtracting it. It's positive, so let's cancel it out. That's it. It's canceled. So over here we got negative 6 minus 1. All right, you owe me 6. You borrow another. Equal sign. 1 minus 1 is nothing. And a positive x is just x. Therefore, my final answer, negative 7. I feel like that was the answer last time. All right, again, I have 2 variable terms on the left. I've got this 7n and this 7n. So altogether I got 14n. And the equal sign would come down. And I have two variable terms on the right also. I've got 1n plus 8n, which is 9n minus 15. Okay. So let's get the variable terms to the left. There's a lot of reasons to do that. One, we like left. People just feel cozy with that. Also, we'll still have positive coefficient. And the other is like our constant terms are already on the right. So why start flipping stuff all around and being crazy about it? So negative 9 minus 9. 14 minus 9 is 5n. Equal sign. 9 minus 9 is nothing. Negative 15. Lots of people lose that negative. So now I've got it down to a one-step equation. 5 times n. We're going to divide both sides by 5. And we got n equals. Negative divided by positive is a negative. 15 divided by 5 is 3. Final answer, negative 3.